Welcome to this Sailing Weather Educast from U.S. Sailing and Sailing Weather Service. I'm meteorologist Matt Sanders, and in this Educast we're going to be looking at the winds and strategy around downdraft clouds. But before we get started, remember that this is an educational lesson, not a forecast, so always check out the actual National Weather Service forecast before heading out on the water. So, as I mentioned, in this lesson, we're going to look at the winds caused by downdraft clouds, and we're going to learn how these winds interact with the large-scale wind to cause the observed wind that we sail in. So basically, the idea is that the wind from the downdraft cloud plus the large-scale wind is going to equal the observed wind we use for sailing. And this will play into some strategy you can use while sailing near downdraft clouds. But as we have in previous lessons, you'll need to rely on your cloud identification abilities we learned in the earlier educasts, specifically that downdraft clouds are typically low-level cumulus that are precipitating, and they're the clouds that we call cumulonimbus. And here's just a quick example. You could see the cumulonimbus cloud is raining and subsequently producing a downdraft of air that reaches the surface of the water and spreads out in all directions. So here, if we imagine that the cloud is over the race course, ideally the downdraft coming from the bottom of the cloud reaches the surface underneath the cloud and moves outward evenly in all directions you can see depicted by the green arrows. And in this example, I'm going to assign a value of 5 knots to that wind moving outward from the cloud. Now, as we've discussed in the updraft cloud lesson, there's always a large-scale wind called the gradient wind caused by high and low pressure centers. And this cloud exists in this wind. And for this example, I'm going to assign a value of 10 knots to this large-scale gradient wind. So in summary, in this location of the race course, there's the wind caused by the downdraft cloud plus the large-scale gradient wind, and the combination of these two winds is going to result in the observed wind that we actually sail in. So some simple addition and subtraction will give us a good idea of what the observed wind is around the cloud. Now, in this location, the yellow area depicts the 10-knot gradient wind, and there was also a 5-knot wind coming from the downdraft cloud depicted by the green arrow. Now, you can see both winds are traveling in the same direction, so they add up to equal the observed wind, which in this area is 15 knots. Now on the other side of the cloud, we also have a 10-knot gradient wind depicted by the yellow arrow, and we have a 5-knot wind coming from the downdraft cloud, but they're coming from opposite directions. So they partially cancel each other out to equal an observed wind of 5 knots. And this occurs to a degree all around the cloud base based on the direction and the strength of the two winds. And in real life, it will obviously not be as symmetric as this idealized example. Now, if we reapply the race course, you can see how this could affect the course you decide to sail. So looking upwind on the right side of the course, the wind is backed, or what some will call left shifted, while the wind on the left side of the course is veered or right shifted. And there's also an important effect on speed. If we again look upwind, you can see that the wind near the front side of the cloud is stronger than the wind near the back side of the cloud. So this could affect your strategy, because in this situation, with the cloud over the race course, when you leave the starting line, you will initially be headed, as you can see by this example of the sailboat, and then you'll become progressively lifted before becoming headed again as you approach the top mark where the lightest air would be found. However, if you have more of an option as to where you can sail in relationship to the cloud, maybe you're in a coastal race or you're just day sailing, when looking upwind, you'll want to at all costs avoid the backside of the cloud because that's where the lightest air will be found. You can think of it as a no-go zone with very light air. And theoretically, the boat sailing around the front side of the cloud would have better wind and reach their destination a lot quicker than the boat sailing around the back side of the cloud, as you can see in this example. And that's going to conclude our look at the winds around downdraft clouds. In the next Edgecast, we're going to look at convergence cloud lines, and we'll see that these occur at many venues, and knowing them can really greatly improve your strategy on the race course. So I'm meteorologist Matt Sanders, and I hope you enjoyed this Educast.